Okay, now we're going to study least common multiple. Now, multiple a product of a number and a whole number. So, for example, if I list some multiples of 2, they are 2, right? 4, 6, 8, 10, and so on. Multiples of 3 are 3, 6, 9, 12, 15, and so on and so on. Alright? 2 times 1 is 2, 2 times 2 is 4, 2 times 3. Alright, so a number and another whole number. That's how we get multiples. Alright, this is what our times tables is based off of. Okay, let's take an example. What is the LCM of 18 and 10? Okay, so what is the LCM of 18 and 10? So let's list the multiples of 18. So the first one is 18. Then we have 36. Then we have 54. Then we have 72. Then we have 90. And then we have 108. Okay, we can stop there for now. Let's list some multiples of 10. We have 10, 20, 30, 40, 50, 60, 70, 80, 90. Now I realize I can stop because we have a common multiple. Now if we continue going, there are going to be other common multiples which will happen to be a multiple of the LCM. So like if we continue listing multiples, the next common multiple will be 180, then 270, and so on and so on. So the LCM is 90. Let's take another example. What is the LCM of 15 and let's say 12? So let's list some multiples of 15. So we have 15, 30, 45, 60, 75, 90, 105. Let's list some multiples of 12. 12, 24, 36, 48, 60. Okay, so we have 60 as the LCM. So LCM equals 60. The LCM of 15 and 12. Lowest common multiple. Okay, now we can also find the least common multiple using prime factorization. Alright, so let's take a look at the example we did previously by listing LCM of 12 and 15. Okay, so let's use the factor tree. So 12, using prime factors, we have 3 times 4. 4 is composite, so we can break down 4. 2 times 2. And we have 15. We have 3 times 5. $12 is equal to 2 times 2 times 3, and 15 is equal to 3 times 5. Now what we're going to do to find the LCM using prime factors, we're going to compare. We have to use every single type of prime we have, but the greatest time it occurs between both numbers. So we have 2's and we are comparing. Now we don't have any 2's in 15, so we are going to go with what we have. 2 sets of 2's. LCM is equal to 2 times 2. Now we are comparing 3's. We have 1 3 here, we have 1 3 here. So none is greater, so we only go with 1 3. So we can cross out this one. We're comparing 5's. There's 1 5 here, we don't have any in the other numbers, so we just go with 1 5. So 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. As we got in our previous method by listing. Let's take another example. What is the LCM of 18 and 10? Okay, so let's use our factor tree for 18. So 3 times 6, 3 is prime. 6 breaks down into 2 times 3. 10, 2 times 5. $18 and 10. So 18 is equal to 2 times 3 times 3. And 10 is equal to 2 times 5. Again, I have to use every single type of prime factor I have, but the greatest time it occurs in either one of the numbers. So I have 1, 2 here. I have a 1, 2 here as well. So I can only use 1, 2. I have 3's here. I don't have any here, so I'm going to go with 2 3's. I have 1 5 here. I don't have any here, so I'm going to go with 1 5. Okay. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 90. All right, let's do one more example. See, what's the LCM of 12 and 30? Now 12, we have 2 times 6, and then 2 times 3. 30, we have 3 times 10, and we have 2 times 5. So 12 and 30, 2 times 2 times 3, 30, we have 2 times 3 times 5. Okay, again we are comparing all prime factors and using the greatest amount that occurs in either one of our numbers. So we have 2's, we have 1 here, but we have 2 here. So we're gonna go with this one. 2 2's. So we're gonna cross out what we're not using. So LCM is equal to 2 times 2. Okay, we have 1 3 here. We also have 1 3 here. So we can only use 1 3. So we can cross out 1 that we are not using. We have 1 5 here, and we don't have any in 12, so we're only going to use 1 5. Two 2's are 4, 4 3's are 12, 12 5's are 60. So the LCM of 12 and 30 is 60.